What's up again, everyone? Today is an exciting lesson because we're going to do math. So we've read some histograms, created some box plots, right? Took some notes on data. So we've got a lot of vocab, a lot of graphical display stuff. We're going to do some math. We're going to calculate some stuff. So let's do it. All right. Of course, this is in our summer assignment. So here we go. I skipped the title. There it is. We're going to find some overall averages when we're combining some samples. This is lesson 5 of 6. We are almost there. Boom. Here's your problem. Do it. That's the whole video. Just do this problem. So, you guys read that? I guess I'll read it too. You know, it is a video. A local statistician surveyed residents, asked how many years they had gone to school, including any time spent at a college or university. So the statistician collected 2 samples, one of men, one of women. Sample of 48 men had an average of 12.89 years of education. And for the group of 60 women, the average was 14.7 years of education. We want to find the mean or average years of education for all of the people surveyed. So we want to think if we combined everyone into one group, what would the overall average years of education be? So you should absolutely 1,000,000% pause this video right now and try something. Right, if we were in class, I'd be telling you to talk to your neighbors and try something. Doesn't matter if it's right, doesn't matter if it's wrong. I mean, eventually it does, but for now, something. So don't just keep watching the video, pause it and try something. Be engaged in these lessons. All right, unpause. So, one of the most common things I would expect to see, the most common incorrect approach, I like to say that, you guys will learn that about me. The most common incorrect answer would be to add these 2 values and divide by 2. Right? So this right here is the most common incorrect answer. And so let's think about that. We learn a lot more from wrong answers than we do from right answers in a lot of cases. Right? So when we're in class and we're talking to each other, don't ever be afraid to raise your hand because, you know, don't be worried it's the wrong answer. Like, so what? Most of the time, I'd rather have you tell me the wrong answer so we can all talk about it and figure out, you know, where maybe it went wrong, where it was good, and what the best approach is. Right? If someone raises their hand and they're like, whatever, 37, and that's the right answer, like, that doesn't help anybody. So take risks. But anyways, whatever this comes out to equal is definitely one of the multiple choice options if this is a multiple choice question, right? So the multiple choice options in stats are based on common incorrect approaches. So why can't we do this? So we've got, the problem with this is treating each of these values equally, right? These are each getting weighted equally. We're treating the men's average the same as the women's average. However, right, hopefully we realize, based on the information given, we had 48 men and 60 women. So it's not really fair to treat these averages equally because the sample sizes are different. So because the women's sample size is larger, they're going to carry more weight. This is going to give us whatever number is right in the middle of 12.89 and 14.7. So if we think about it as a number line, we got 12.89 right there, 14.7 right here, and this approach that's circled, all that's doing is finding the middle number, adding the 2 and dividing. So if we do 12.89 plus 14.7, whoops, 12.89 plus 14.7, that tells us the middle is 13.795. And so that 13.795, that's going to be one of the multiple choice options if this is a multiple choice. But again, that's incorrect because the sample sizes are different. If they were the exact same sample size, that would have worked. But here, right, this is our men group and this is our women group. Because the women's group is larger, their average is going to carry more weight. So the actual final answer should be closer to this 14.7 than to this 12.89. So if you were doing a multiple choice, you could cross off 13.795 because the sample sizes are different, so the average isn't right in the middle. And you could cross off anything that's over here. That's between 12.89 and 13.795. The average isn't, the overall average for all 108 people isn't going to be closer to 12.89 because the men group was smaller. The overall average for all 108 people is going to be closer to 14.7 because the women were the larger group. So the problem with this method is this method right here does not consider the fact that there are different sample sizes. So now the question becomes, well, how do we find the average? And there's a couple ways we could go about doing it. We could think about proportional reasoning, or we could, I don't know what it's called, so I don't really have a segue there. So, or we could do something else. So let's see. So let's do it. Like, that's the whole video, is us doing this problem. So this table right here is just summarizing the information. Notice how I use some subscripts. So N, the sample size for the men's 48. X bar, that was what we saw as the sample, the symbol for mean. X bar for the men is 12.89. Same idea over here for the women. So here's one way to approach this. One way to do this, if we were going to put all this data together, we would have 108 total people, right? 60 women plus 48 men. Now, I don't know each of the 48 men, for each of the 48 men, I don't know their individual years of education. I know the average is 12.89. But for instance, for the men, I would have 48 different numbers listed. I don't know what they are, so I can't list them exactly. My best option is I could pretty much assume each of these 48 men had 12.89 years of education, right? Now, that's not true. They would all be different, but this is my best guess, right? That's the average. So if you think about it, I could list 12.89 40 times. And then for the women, right, I could do the same kind of thing. I don't know each of the 60, for each of the 60 women, I don't know their individual years of education, right? I can't list all 60 of them separately. My best bet would be to just assume all 60 were 14.7, which I know wouldn't be true, but the average is a good guess. So I could list 14.7, 14.7, 14.7, and I could list that 60 times. Now, theoretically, if I put 48 12.89s in L1, and then below that added 60 14.7s, so I had 108 numbers in L1, and then I did stat calc 1 var stats, that would give me the correct answer, right? But we don't have time for that. Unfortunately, in AP stats, not only do we have to know how to do the stats, we got to know how to do it pretty efficiently. But to find an average, right, I would do 12.89 plus 12.89 plus 12.89 plus 12.89, right? I could add 12.89 40 times, then I could add 14.7 60 times, right? But again, I don't have time for that. But if we think about it, adding 12.89 40 times is the same thing as 12.89 times 40, right? That's the definition of multiplication. And adding 14.7 60 times is the same thing as 14.7 times 60. So rather than adding 12.89, right, 48 of them, I kept saying 40, oh my bad, that's 48. Hopefully that didn't blow your mind and ruin this whole video. But I could add, rather than adding 12.89 48 times, and then 14.7 times 60, then adding 14.7 60 times, I could take this multiplication shortcut. Now to add all 108 numbers, I could take whatever this comes out to be plus whatever this comes out to be. And then we would divide by the total number of data values. Now, right, you don't have to think about all this craziness that I'm doing. I'm just trying to explain where this comes from. Ultimately, what we're going to do is we're going to have 12.89 times 48 plus 14.7 times 60, all divided by the total sample size, which is 108. And this, in orange, is how we can calculate the overall mean. I was just trying to reference that where did this piece come from? It's this idea that we're theoretically adding 12.89 to itself 48 times. Where did this come from? It's theoretically from adding 14.7 another 60 times, right? But we can take a shortcut with some multiplication there so we don't have to add 108 numbers. All right, and this is the total number of numbers that we added, which would be 108. If you're a formula person, I challenge you to try to use some variables here and turn this into a formula. Another way to approach this is just to think proportionally. So another way to do this would be for the men, right? Their average was 12.89, plus for the women, their average was 14.7. But we know we can't just add the averages and divide by 2. So what we could do is we could say there were 48 men out of 60 total. Out of 108 total participants, plus there were 60 women out of 108 total participants. And so we could multiply each average by the proportion of people who were either men or women, right? Here we're multiplying this average by the proportion of percent that were women. Here we're multiplying this average by the proportion of percent that were men. And so this is another way we can approach this. And then if you know some algebra and use some common denominators and stuff, this ultimately is the same thing as 48 times 12.89 plus 60 times 14.7, right, all over 108. So whether you like this top idea, kind of thinking more proportionally, or this idea, thinking about adding up a bunch of numbers, right, both work. But the more conceptual takeaway is that we have to factor in the sample size. So do that. I don't feel that good about that explanation. I'm gonna have to go re-record this video someday. Anyways, all right, started babbling. Let's wrap up with one more question here. So this is actually an AP multiple choice from an exam. So admin at a state university computed the mean GPA for juniors and seniors majoring in either physics or chemistry. The results are displayed in this table we got at the bottom. And so the question is, when we combine juniors and seniors into one group, right, put everyone together, just like we combine men and women, is it possible that physics majors have a higher overall average GPA than chemistry majors? Now, of course, we know, I hope, right, we definitely know we can't just say, oh, the average here is 3, right, add those and divide by 2. The average over here is 3.3, add those and divide by 2. No, can't do that. That fails to consider sample size. So let me show you here. These are your options. So could the physics group have a higher average than the chemistry group? You know what? What if there were like 8,000 physics juniors? I'm sorry. I'll take that back. What if there were 8,000 physics seniors and 1 physics junior? And then over here, there were 8,000 chemistry juniors and 1 chemistry senior. This chem average is going to get pulled really, really close to 3. Like it's going to be almost 3 exactly. And this physics average is going to get pulled really, really close to 3.2. So it is in fact possible, right? If there's tons of physics seniors and tons of chem juniors, the physics average, if there's lots of seniors with these made up numbers here, would get pulled closer to the 3.2, and the chem average would get pulled down closer to the 3, and so the physics could end up being like, this could be like 3.19, and this could be like 3.04 over here. I'm just making up numbers. So yes, it definitely is possible. And the key is, it's about the sample size, right? It's about how many of each we have. It's not about spread. It's not about shape. It's about the numbers of people in each group. And so that's a more, challenging conceptual version of kind of the procedural math that we just did. All right. So that's it. That's the end of lesson 5. So that was a short one for us. I might have to do it over again though. Until then, we'll leave this one up temporarily.